Good morning, friends. In my last video regarding the alkynes, I explained you the preparations of the alkynes. Now today I will explain you the chemical properties of the alkynes. You see, alkynes, they are having the triple bond between carbon atom and they are the most reactive in nature. It undergoes addition reactions, oxidations, and the most important property is the acidic property. You see, acidic property means when the molecules or the compounds reacts with metals to form their salts and the hydrogen gas is released. Now in the case of the alkynes, that is the triple bond, one important character is that only the terminal alkynes, that is one alkynes, they show the acidic property. Again listen, only the terminal alkynes, that is one alkynes, they show the acidic property. Now acidic property means they must give out the proton. Now first I will explain you the reactions, that is ethyne reacts with metal sodium at about 475 K. In first step it formed the monosodium acetylide, and in then second step it formed the disodium ethylite by the release of the hydrogen atom. And if we take the example of the ethyne with sodamide in the presence of the ammonia at about 195 K, it formed the disodium ethylite and hydrogen gas is formed. This is the simple reactions where ethyne shows the acidic character, that is hydrogen gas is formed and the salts are formed. Now how this terminal alkyne behaves as acidic? You see, in the case of the acidic character, proton should be formed. Now in the terminal alkynes, carbon is directly attached to the hydrogen atom. Now here we can explain this thing by sp hybridization. See, in s orbital electrons, which is more tightly held than in p orbital to the nucleus, because s orbital is more close to the nucleus. So s character is more dominant, that is 50% about. So carbon atom become more electronegative and release the proton. Again listen, this release of the hydrogen atom or the proton is due to the sp hybridization, s and p hybridization, and we know that the s orbital electron is more close to the nucleus, so it is more tightly held as compared to the p orbital, and so it has more character of the s, that is more than 50%. So carbon atom, that is the electron, they are shifted towards the carbon atom to form the more electronegative character and then release the proton. So here cleavage takes place between the carbon and hydrogen. Now carbon, when become more electronegative, then it releases the hydrogen proton. This is the explanation behind the terminal alkynes, which shows the acidic property. Now if we take the two alkyne, then there will be no hydrogen atom on the carbon atom, so it will not show the acidic character. Now again, second reactions, that is ethyne reacts with ammonical solution of the cuprous chloride and also the ammonical solution of the silver nitrate. Now, in the case of the ammonical cuprous chloride, it forms the dicuprous acetylide that form the red precipitate, and with diammonium silver nitrate, it forms the white precipitate that is the silver disilver acetylide. Now, it is a test. It is a test for the alkynes. Red precipitate with cuprous chloride and white precipitate with diammonium silver nitrate. It is a test. So the point is that how terminal alkynes they are acidic nature. Simply due to the sp hybridization, s orbital is very close to the nucleus, so it is tightly bound, and the electron of the carbon hydrogen is shifted toward the carbon to form it more electronegative, and then release of the proton takes place. Okay, so this is how the acidic property of the terminal alkynes can be explained. Now, addition reactions. First, addition of the halogens. When chlorine reacts with ethyne in the presence of the carbon tetrachloride, first it forms the 1,2-dichloroethene, and in second step one more bond breaks and it forms the 1,1,2,2-tetrachloroethane. So addition takes place in two steps. First, one pi bond breaks, then second pi bond breaks, and finally it forms the 1,1,2,2-tetrachloroethane. Now, in the case of the bromine, you see bromine is orange brown color. When bromine reacts with ethyne and carbon tetrachloride, it forms the tetrabromo, which becomes colorless. Here, brown color of the bromine water disappear and it forms the tetrabromoethane, that is the colorless. So it is a test for the unsaturation hydrocarbons. Now, addition of the HCl. See, as it is a triple bond, so reaction always takes place in two steps. In first step, ethyne reacts with HCl, then addition of the HCl takes place, it forms the CH2, CHCl, that is a vinyl chloride. Now listen, in second step, how this HCl will act. Here it will follow the Markovnikov's law, that here in the case of the vinyl chloride, negative charge always goes to the carbon atom which has less number of the hydrogen atoms. So in vinyl chloride, it forms the ethyladenine dichloride, that is the second negative charge particle goes to the carbon atom having the less number of the hydrogen atoms. So this is the addition reaction of the halogen and the addition of the HCl, and here I explain you that the terminal alkynes, they show the acidic property. So if you like my videos, please share and subscribe. In my next videos, I will explain you more addition reactions and the oxidation reactions. Thanks very much.